But I want to let you know that the popularity of that tour spawned the idea of taking tours to various sites, relevant sites to the National Atomic Museum's ideologies. And so what we decided to do was take bus trips within a day's drive of Albuquerque to all kinds of interesting locations around the Southwest. So day trips include the very large array down near Socorro, of course the Trinity site. We go to Los Alamos, and then there'll be a new tour next year, if things work out, down through the southwest part of the state, Alamogordo and the Space Museum down there. Then we do some great overnight trips to Amarillo, Texas, to the Pantex plant, Carlsbad, New Mexico, to the WIP facility, which is a wonderfully interesting and educational tour. One of the more popular tours is Nevada Test Site, where we take 3 days and go over to Yucca Mountain and Mercury Flat and check out that whole operation over there. And then this year we introduced a very popular trip up to Colorado Springs, where you can visit Cheyenne Mountain, the Air Force Academy, Schriever Air Force Base. And finally this year, our other new one will be still to come this year in November, a trip down to Tucson, Arizona, where the Pima Air Museum is, which is a huge facility for aircraft and spacecraft. And then there's, if I'm not mistaken, it's the only remaining, Jerry, correct me if I'm wrong, only remaining Titan missile silo. And you can actually tour that thing and go walk down in the silo and look at the control room and all that sort of thing. So all those opportunities exist for very, very reasonable cost through the National Atomic Museum. The other reason I'm plugging it is because we have found through questionnaires that we've passed out that the best way to propagate the tour series is by word of mouth. That is, satisfy customers. And I'm confident you're going to be satisfied with the tour you experience tomorrow, so I'm asking for your support in telling your friends about it. Tell them about the Trinity Tour and tell them about the National Atomic Museum's Scientific Tours series. And then don't forget to participate yourself on some other tours. They are the best value you can find anywhere. My commercial's done. It's my privilege to have our speaker here tonight, a gentleman that I just met, well, a year and a half ago or so. But he's a legend in his own time. He's the only guy I know whose picture is up in a museum. But it's not because he's old. It's because he participated in a very historic event. He was just a strapping youth back in '45 when, well, I'll let him tell you what happened down there at Trinity site, but Ben Benjamin actually participated at the Trinity test. And he was a photographer charged with documenting the event. And he'll tell you all kinds of things about that. But what I like most about Ben is the fact that, first of all, he can't be old enough to have been around back then, but he is the sweetest disposition and the most gentle gentleman I know. And it's a privilege for me to have him address you tonight. So I'm going to bring up one of the real guys that was really there to tell you about what you're going to see tomorrow, Mr. Ben Benjamin.
I didn't put on my equipment as I was told to do. But, I think I can make it, Jerry, that on. And, hello. Does that do it? Well, Tony, thank you very much. That's amazing. You got to be a real good salesman. You're going to sell all that stuff over there, I'm sure. The first atomic bomb in southern New Mexico, the Trinity event, the most significant event of the 20th century, or that's my take on the event. It ushered us into the atomic age. And I was there. I was in the Army, and I was a sergeant, and I was with the Manhattan District Engineers, and I got assigned to Los Alamos because I had had some experience making lenses and prisms for fire control instruments. I had worked for Honeywell in Minneapolis, and the guy who turned out to be my boss at Los Alamos was Julian Mack, a professor of physics from the University of Wisconsin. He needed somebody to start an optical shop and build some prisms for a camera he was building, a camera that took pictures at the rate of 1 million pictures per second. And those kinds of cameras are still available. But the prism was very special, and another GI who had worked for Land Camera Company and myself worked on those prisms. But our boss found shortly after we made the first one, he found a commercial supplier, and he made very good prisms, and that turned George and I loose so we could do other things that were needed to be done around Los Alamos Laboratory in the way of scientific photography, very high-speed photography with Fastax cameras, several thousand pictures a second, and I did some photography of X-ray photographs of the pouring of liquid high explosives into molds. They were having some problems with bubbles forming, didn't know quite where they were forming or how, so we watched the pour in X-ray, and I took pictures motion pictures with a 35 millimeter camera. And there were all kinds of jobs like that around the lab. I'm not going to go into a lot of that. We want to talk about Trinity, the first nuclear explosion in the history of the world. And this is a pretty good slide here, except it looks like this tower is 100 feet high. Looks like it's tipping over. That's distortion due to the camera. That it was a vertical tower. This is up at Los Alamos, and that's me in the Jeep. We had just been to the donut shop, and we got a bag of donuts there. I don't know what the occasion of taking the picture was, but that's the first picture I can remember. Here's a picture of a couple of my buddies at the orderly room. This was in some ways, a very ordinary Army organization. Here's some pictures of me and my buddies after working late one night. We were preparing some experiments in preparation for the Trinity shot, and we worked out in the cold on the mesas up there. And when we got back to the lab, we had this little room that was warm, and we gathered in there. And Curly, one of our buddies, he was up on a shelf up top here and took a picture of us straight down. Curly was a good photographer. This is still at Los Alamos, and it's a picture of me with a spectrograph, which some of you, I'm not going to explain it, except that it analyzes the light that comes into it. It's an instrument that was built in England, a Hilger and Watts spectrograph. We had two of these that we used down at Trinity, and the optics is all quartz so that we could, so they would transmit the ultraviolet radiation, and we could see deep into the ultraviolet light. And we knew that if the bomb worked properly, I shouldn't say that, I was just a technician there. I was not one of the scientists. I was just a child, as you can see. But I was given, we had a project scientist doing this, but I did the legwork, the easy stuff, in preparing the spectrographs. So we did a lot of work at Los Alamos before we went to Trinity, but this is base camp at Trinity. And I should say I was there today at Trinity. I went with the Sandia's weapon interns. We have a group of people at Sandia Labs. While I retired, I now have a contract to work with them, and I come in and help them. They have to learn how we used to do it in the good old days, so I'm helping them with that. But this is base camp at Trinity, and the photo-optical group, this was the McDonald Ranch headquarters, ranch house right here. All this other stuff, except that one, all this other stuff was moved in. This had been barracks and a mess hall that had been at some CCC camp. And the contractor found this and brought it in. But this is out in the middle of nowhere down there, and you won't see this tomorrow because all this stuff is, the only thing left down there now is this, which was the ranch headquarters, and this structure, which was an adobe structure that was there before the very early building, and this was kind of an office area here, and this was a photo-optical lab. We had a lot of cameras and equipment, and we got there first, and we just took over that place. And it was very convenient. There's the mess hall right across, and these are barracks buildings, mostly barracks buildings, some warehousing back there. It's been 55 years. I've forgotten some of this stuff. But I'm going to talk to you a little while later about my friend Ernie Wallace, who was in the Army with me. And Ernie, he was very interested in rattlesnakes. And I'll show you his Jeep soon. Maybe that's... Ernie's Jeep had a big box on the back, and he had sticks. And Ernie was able to catch rattlesnakes down there, which he did. He caught a whole bunch, and he built a cage for the rattlesnakes right out here in this corner. I don't see it there, but that's where it was. And he had a bunch of them in there. He collected them all the time. And one night, some animal dug a hole underneath that cage, and the hole was big enough. The animal went away. He ate his fill, I guess, of snakes or whatever. And the snakes were all over this camp. And the next morning, guys were stepping out of their barracks and going over to the mess hall and yelling and screaming and hollering. And so there were quite a few GIs like myself there. And we had one, a lieutenant, who was really the guy that ran the MP contingent down there, but normally a very nice guy. But he came around to Ernie, and he said, "Damn you, Ernie, you go find those snakes." Some of the guys were almost bitten. So far, we were fortunate. Nobody got struck by one of those rattlesnakes. So Ernie had a job of finding those rattlesnakes and getting rid of them. And he was warned not to bring another snake back into camp. Is it visible here? Yeah. We had a water problem down here. There were windmills here, and the water from the ground was not potable. And the rancher here had built a cistern. You can't see it, I guess. Maybe that slab is it. Anyhow, the runoff from the roof went in there, and that was we started with that being the drinking water. But then we started to take a truck into San Antonio and get 500 gallons at a time of good drinking water and bring it out. Okay, and I mentioned a cistern there. That's me, and that's my friend Ernie, Ernie is this guy, Ernie Wallace, and he did most of the documentary photography, but he didn't do this one, obviously. If you have friends with cameras, that's what they do. They find you in embarrassing situations and take your picture. But we'd probably been up the night before on some important job, who knows. We had no recreation down there. We provided our own. So we went over to this is a McDonald ranch. Whoops, this is a really important McDonald ranch. This was about 6 miles from the ranch house I just showed you in that picture. And this is the ranch house where the assembly of the plutonium pit was made. But long before the plutonium pit got down there, we were working down there, setting up the range and getting the cameras all squared away. And this tank for water was empty, and the windmill had blown down. So I remember I was involved with some other GIs who said, we ought to get an engine and hook up to that pump. Seems will probably work, which it did. But we got an engine in there and pumped water, and we made a nice, and after dinner in the evenings, we'd go down and go swimming. It was hot down there in the summertime. But you'll see that tomorrow when you get to the McDonald Ranch. You'll see that tank. There were other recreational things we did down there, and that's me, and that's an antelope that I said to Lieutenant Bush, the most ranking officer, most ranking Army person down there, that I'd like to go kill one of those antelopes. They were all over the place. He said, if you want to kill one, you go ahead and kill as many as you want. He said, I'm the game warden down here too. So I had my friend drive the Jeep, and we didn't go a mile after dinner. We went out there. We didn't go a mile from camp. There's this huge herd of antelope, and I killed one of them. Then I wondered what am I going to do with this? So I went back to camp with the antelope in the back of the Jeep, and as I say, it was after dinner, so I went out and found the mess sergeant. He was laying in his bunk in the barracks. And I said, hey, Sarge, I just killed an antelope out there. Would you like to have him? And he jumped right out of that, and he said, boy, I sure would. He says, oh, we're running short of meat out here. And so he ran and got his apron and his knives, and we took this thing into our garage there and our maintenance building, and I went to work on him. The next evening we had beef stew for dinner. Didn't taste too good, but he complained that the civilians at Los Alamos would come down to Trinity site and to stay there and eat there. And he had to get his rations from records that said how many people were, and those civilians wouldn't announce their arrival, and so he had a legitimate complaint, I think. And occasionally he'd send the MPs out, and when the McDonald's took their cattle out, they missed a few of them. He'd say, go out there and find one of those steers and bring him in here. We need some meat. And they'd take the 6x6 truck out there and a machine gun and kill one of those cows. Lieutenant Bush's dog thought he owned this antelope. This Tuffy was his name, and he took over. And those are sort of recreational things. Occasionally on weekends we'd go scrounging around, and this is down on the right near the Rio Grande River in a ghost town named Valverde. It became a ghost town when they put in the dam in 1912. What's the dam down there? The Elephant Butte Dam. And Valverde became a ghost town because the water came up into some of those adobe houses there. But anyhow, we went by there, and here's these two guys. They were Mexican nationals working for somebody, and they were running these sheep down there. So I asked these guys how much they wanted for those sheep, and I've forgotten the numbers, but it was a few dollars they wanted per head. So I went to Dr. Ken Bainbridge, who was our test director at Trinity, and he was a physicist from Harvard University. And I said, Dr. Bainbridge, I said, we met these guys with all these sheep, and I said, they'll sell them pretty inexpensively. Why don't we get some and stake them out here? See what happens when the bomb goes off, and maybe learn something from that. And he says, that might be, he says, let me talk to the other guys. I'm sure he was talking to his peers, and he said, I'll get back with you. When he came back, he said, well, we're going to know the overpressure in the air everywhere that would kill these sheep. He said, so I don't think we need to do this. So we called off that project. But a few years later at the Nevada test site, that's exactly what they did with, except they used, instead of sheep, they used pigs. And in fact, there's still a place at the Nevada test site where people stay. It's called the Pig Farm, and it's where they kept a huge number of pigs for that purpose. This is Trinity Base Camp, and a slightly different picture. This is the old ranch house, and that was, again, that was our lab, the photo optics group. And this you can just see a trailer here. We built a little photo lab in that trailer up at Los Alamos and brought it down so we could process film. We didn't process the data film that we took here because we didn't have good temperature control in there. It was so hot. But we called it slopping some film. If we just wanted to test the camera, we'd slop some of the film and look at it and then throw it away. We didn't have to have real good control on stuff like that. As we didn't use that trailer for any really important film processing. But this turned out to be a great facility for our photo-optical group. And here are some of the vehicles that, now I remember riding in this stretched vehicle one time coming down from Los Alamos. Went back and forth quite a few times during this period of several months down at Trinity. Usually, this is the only place in the Army I was ever stationed where we had more vehicles than we really needed. You get up in the morning, and if you wanted a Jeep, you'd take a Jeep. If you wanted a weapons carrier, you'd take one of those. And so we had all kinds of vehicles. Here is the front of this, the front of our our ranch house, and that's me. And you can see by this time we'd picked up a few mementos around the desert. This is, Ernie liked to take pictures of me. I was the only one in our group that had a campaign hat, and I think he liked that hat, and therefore I had a lot of pictures taken of me. But I still have that hat. I should have worn it tonight. And this is a hookah pipe. You put the smoking material up here, and you suck on this thing, and you bubble smoke up through water in this thing. And then in here it was very cool smoke. And I was going into chem stock at Los Alamos to get some glassware for the photo trailer, and I had been reading about a hookah pipe. So I brought down enough glassware to make that. And that's really tobacco I'm smoking in there. I know that's hard to believe, but the truth. This is right across the street from our facility, and it's the mess hall. This is about, the guy that did the documentary photography, we didn't have hardly any pictures. There he is standing there in the chow line. And this is his Jeep with his box. That's his rattlesnake box. And he had two sticks, one forked stick that he'd stop the snake, and another one with a little loop on it. He could catch him and put him in that box. And don't know why he did that, but he seemed to think it was great. This is the day President Roosevelt died, or I think it was the day after, but this flag is right out front of our facility there, and I've forgotten the guy's name that raised the flag every day, but he went out there and he put it at the top, and I said, "Hey, Joe," or whatever his name was, "the president died, you got to put that at half-mast." So then I think I took this picture. It's kind of a crummy picture, but that was, I've forgotten the date, but I've got it listed here somewhere. It was in April, I believe. Does anybody remember when Roosevelt died? And this is one of the vehicles we had lots of, and I don't know what the occasion was, but that's a picture of that vehicle. And this is a very important, I don't know what's going on there either, but it's been a long time. We were very happy guys, as you can see. And here's an actual working picture. You didn't think we had any, did you? This is George and I, and we had this was my experiment. Now, if you did this today around here or anywhere, you'd get fired and your boss would get fired. This is high explosives. These are half-pound charges of Torpex. And we were using these as flash lamps. From 6 miles away, we wanted to get, well, let me start earlier. It was decided that we should have a photographic method of measuring the velocity of the shock wave when this bomb went off. We had some electronic systems, but people weren't too sure that stuff was going to really work. So my boss drew a sketch for me of what a shock wave switch should be, pretty simple thing. And I went over to the shop, Los Alamos, and had I've forgotten the numbers, had a whole bunch of them built, and we tested them out on the mesa at Los Alamos. They worked very well. And then we came down to Trinity, and we brought this, George and I were not explosives experts, but we threw all these in a box and put them in the back of the vehicle, and we threw the primer cord in there, and these tetryl pellets, and the detonators, we put it all in there. We found out later, after reading some material on explosives, that this is one thing you never do. You don't put the detonators and the boosters and all that in one box. But we're gluing these, that's glue in there, and we're gluing this stuff together. But that's on the hood of the Jeep. Can you imagine nowadays working out with and putting your explosives on the hood of the Jeep along with the boosters on them? But that experiment was it was a noble experiment, but nobody knew about the electromagnetic pulse, or EMP as it's now called. But when a bomb goes off, a bomb that big, you get a tremendous movement of electrons, and it sets up a current in every wire within miles. And of course, the bigger the explosion, the more of that you get. And the detonators that went with that explosive system at each location, they all detonated when the device exploded, when the gadget exploded. It was called the device, the bomb was called a gadget or various other names. And I'll show you the gadget here shortly. In fact, now it's time to, let's have the movie. I know there's a switch here someplace. There it is. See if I can get this underway. Okay, movie. Whoops. Movie time.
I think I got it going out there for you.
Oh, okay, good.
Keep going.
Should you turn off some lights here? Oh, you got them all. It's all set. Yeah, I guess. Is it going? Okay, now I just recently saw a tiny bit of this. So I'll do what I can. This is the Fat Man, the explosive device, the gadget. And this is the tower that you saw pictures of. And it's being, I think this is a trial raising that up with the winch that's up on top of the tower. And I think this is the trial hoisting. Most of the color film that we took down there by now, it's a mess, but the guys here went over it with some schemes they have, and it's pretty reasonable film now. a lot of milling around here, but
You know how much it weighed then?
pardon?
You know how much that thing weighed?
Well, the completed device was 10,000 pounds, and this was, I think there was 5,000 pounds of high explosives in this sphere. That was the explosives that imploded and activated the nuclear materials, which in this case was plutonium. The first bomb that was dropped on Hiroshima was the gun-type bomb, and it had uranium core. And it was a gun-type weapon. I'll talk to you a little about the difference here shortly. But that's, over at the museum you will see, if you haven't been there, you'll see a Fat Man bomb, and you'll see it from the outside of the aerodynamic shell that's on it. And but this is the active part of it right there. Now, there are no detonators on it. You'll see it on another picture with lots of wires. There are 32 detonators on this thing so that the explosives would burn inward simultaneously and provide the implosion that would crush the nuclear materials, and the fission would then occur. Say that again. Why didn't we? Well, I don't know. I wasn't involved in it. I was in the photographic group. I think they did test it with weights or something before they hooked onto this thing. But you'll see. I think you'll see later. Some of the guys got, when the device was just a few feet in the air, they sent a vehicle down to base camp, and they gathered up all the spare mattresses they could find, and they put them down there in case it would fall, as if that would help.
Is this getting ready for the July 16th explosion?
Yeah, we're
How
getting.
long did it take to get all this set up?
Well, this was just a few days. I'm not sure when this was, but they didn't raise that thing until, I think it was the day before, on the 15th, is when they raised the device up onto the tower. But this is probably a couple days before about the 13th, 14th of July, and the detonation was on the 16th. There was great pressure to get that device tested. President Truman was in Potsdam with Joe Stalin and Winston Churchill, and they were having a big meeting about how they're going to chop up Europe, who's going to get what, and so on. And President Truman was hoping that he'd get some word about this test so that he would act a little differently if he knew this thing worked properly.
Point out some of the more notable personnel in the film.
I don't know these guys. I can't tell who they are. Well, I do too. I think there's Oppenheimer right there. That's Oppie, without his pork pie hat. So I know one of them. I work with interns over here, and I tell them all, well, Oppie and I did all this stuff. I don't think they believe me anymore. But you can see it's pretty hot down there. These guys are sweating. There's a little more of this kind of footage than we need, but and these taped up areas are where the detonators go. I think you'll see it soon with detonators. I must say, I was in the photo-optical group, and we had, as I say, we had stations at 6 miles west, 6 miles north, 800 yards north, 800 yards west, one station at 20 miles, and we had lots of cameras. But there was an effort at Los Alamos to, don't come and ask these guys what they're doing, it's none of your business, you know. You have to have a need to know. So especially with us GI soldiers, they didn't want us asking one. In fact, that was laboratory wide, and in fact, since we were part of Los Alamos here first, the same thing applied here in the early days of this laboratory. Well, there's more of this than we really need. I should have looked at it before we... And the objective of, someone asked me today, I was down at the Trinity site today with the people I work with at Sandia Labs, the weapon interns, and somebody asked me why the tower, you know, why not just set it on the ground? The idea was, I didn't know it then, but they expected that the radioactive materials in here there would be some fallout because all of this metal would vaporize and the tower would vaporize and it would be radioactive and it would fall on the ground, and in some places it would, if there were people, it would be enough to be damaging to the people. And they didn't know much about that, but we had a shot in May, a couple of months prior to this, with 100 tons of high explosives. I'll show you some pictures in a minute of that stack of. We had a whole freight train come in from Fort Wingate with 100 tons of, I think it was Comp B, and detonated that May 7th, and everybody who was going to be on the big test was in his same position. In other words, it was a dry, not really a dry run, but it was a test of a prelude to the big test. And it was very valuable. Except I was at my 6 mile station where I would be for the big test, and I was disappointed. 100 tons is a huge explosion. But at 6 miles, to me, it didn't look like much. But I wasn't disappointed when this thing went off. Now the detonator cables are on. Each one of these goes to a detonator, and one of the big problems at Los Alamos was, here's the explosion. And you'll see it, the first few frames were completely overexposed. Now it's cooling down and getting in the exposure. We didn't have automatic exposure control in those days. We set the camera and that was it. So we had a lot of these, this is 35 millimeter motion picture photography, and as I say, we had about 50 cameras down there, and we missed on several of them, but we had enough of them that we got a lot of good photographs too. Most of the pictures, when you see something on TV, a movie of a nuclear explosion, it's usually one of these Trinity shots. Now this was one of our cameras at West 10,000. I'm sorry to say it got turned somehow. It wasn't pointing where it was supposed to be. And it had a very long focal length lens, big enlargement. But it turned out to be one of the most spectacular scenes. And you see this very often. This footage is in some library out at Hollywood. And when they show a nuclear detonation in a Hollywood picture, they always use this stuff, and I think it's very effective. But it was really a kind of a mistake. We should have been pointing over at the center of the explosion. "100 pictures per second here, that's 4 times the normal speed of it. In other words, slow motion by a factor of 4. These Mitchell cameras were the same ones that were used in Hollywood in those days, except the company, the Mitchell Camera Company, hand-picked and did a little work on the motion, the mechanism of the camera, so that they'd run nicely at 100 frames per second. And they built a special motor for 100 frames per second. You see how the first few frames were completely overexposed, but there was a few seconds of good photography there. Is that the end? It must be. That's the end. Okay. Won't be long now, folks. Now, I got to go to base. Why don't I? Oh, there it is. Now, this is at 6 miles north and 6 miles west, those photo stations. We had a machine gun turret from an infantry truck or infantry tracked vehicle of some kind. It wasn't a tank, but we took the guns were removed and we put motion picture cameras on it. We knew that, I didn't know, but the physicists knew that when an explosion like this, the ball of fire is very hot and it's going to rise up through the atmosphere. And then the wind's going to move it in whatever direction it was blowing. So both stations, we had a machine gun turret. We placed the machine guns with cameras, and we then were able to track the cloud wherever it went. And we had 4 cameras, various focal lengths on each of these turrets. Then we had a lot of fixed cameras that just looked fixed to the top of the roof of our structure here. And I think I have a picture of that coming up. Oh yeah, in fact, I was at West 10,000 and my boss, Julian Ellis Mackey, the professor of physics that I spoke of from University of Wisconsin, he decided he's going to run one of those. And so this thing that I spent a lot of time preparing. So Julian was sitting in it and I was standing beside, and we had 1,000 feet of film, even at 100 pictures per second. That's a lot of film. So we didn't need a relay closure to start those cameras. I just reached down and I was standing beside him. He was down sitting in this turret. And of course, this is before we had the cameras on it, but I had to try it out, see if I fit in there, which I did. But Julian, let's see, what was I talking about? Yeah, Julian was running the turret, and I was assisting him. I turned the cameras on, and I put the glass that we all were issued. You couldn't look directly at this thing. It was. They say it was bright. It was as bright as 20 suns. I don't know if that's the right number or not, but it was incredibly bright. And of course, it was absolutely spectacular when it detonated. This bright light lit up the whole valley and the sky, and it was extremely spectacular and awe-inspiring. And the mountains in the background were lit up brighter than daylight. And I was I was looking through this glass, and then in a couple of seconds the brightness went down, and I took this down, and Julian was running his turret, and the cameras were all working. But I said, loud enough for him to hear, I said, "My God, it's beautiful." And he came right back and said, "No, it's terrible." And it gave me, I was really elated that this thing was, because people were concerned, is it going to work or not? And it really worked. So I was elated, and Julian sounded, well, he was thinking of the moral implications of what we were doing there, and so it sort of quieted me down for a little while. And to our central control bunker, where the device was detonated, was at 10,000 or 6 miles south. 6 miles south of ground zero. And this is the kind of wiring, signal wires and communication wires we had to each station, not just camera stations, but the radiation measuring stations and other stations. The closest people on this test were 6 miles north, south, and west. And we had some people at 20 miles. But we had these hundreds of miles of cabling all over the range. Oh, and I was talking about Ernie and rattlesnakes. It's hard to see these rattlesnakes, and be careful tomorrow because it's possible. There's a rattlesnake there. It's not a very good picture, but Ernie wasn't around on this one. We let him go. Dr. Bainbridge was quite interested in the rattlesnake population and so on. He was, as I say, our test director. And I think it goes this way, doesn't it? Yeah. This is Dr. Julian Mack and me, and we were out looking for the 20-mile station. Didn't get settled down until we were quite near D-Day. But we were out looking for a place for those very distant cameras. And this occasion, and this brings me to, you see there's no spare tire on that vehicle. And we drove these things from Los Alamos down to Trinity. And one day they said, wow, there's a big tire shortage in the military, and from now on everybody drives without a spare tire. So we had to drive from Los Alamos to Trinity without a spare tire until one of the guys had a flat tire down south of Socorro someplace, and he just put the car on the side of the road, and I think he took the tire and went to town trying to get it fixed. And he did that, but by the time he got back, that pickup truck he was driving was gone. Never found it. One of the local people down there needed a pickup, and it was gone. So they said, okay, you guys that are traveling back and forth to Trinity, you can have a spare tire. But here's one without. That's Julian and myself. Julian, he was, I don't know, he was a little over 40, and he was an old man. We all consider him an old man. This is the Mitchell camera that I spoke about with the 400-foot magazines. We had, as I say, we had 1,000-foot magazines. But we also took some documentary pictures of the antelope, and there was a couple of herds of wild burros down there. I don't understand how those ranchers would put up with those burros eating the grass down there, but there were a lot of wild burros. And we took some pictures of those. And we, as I say, we had a 100-ton shot on May 7th. And here is a picture of, there was a whole freight train came into the Pope siding, which was 25 miles from ground zero. And they had built a road down to that thing, primarily for the jumbo, which I'll show you in a minute. But we also brought these boxes, 50-pound boxes of Comp B, I think it is, up to this tower. And we had a bunch of 6x6 Army trucks, and the guys were going back and forth about as fast as they could. And I was down there with one of the other guys in the Jeep, and we were coming back. We were behind one of these 6x6 trucks, and these boxes were falling off of that thing. And we stopped and picked them up and put them in the back of the Jeep. We filled up the back of the Jeep, and then we started putting them on the hood of the Jeep. So, and Ernie was looking around to drive the thing, and we got up to the location of this tower, and we drove up beside those guys that were driving that 6x6 truck, and we said, hey, you guys dropped a few of these things off. And these guys' eyes bugged out about that. Fortunately, this stuff is very insensitive. Oh, here's a little Comp B, yeah. Composition B. It says right there. Okay. Oh, and this is down at Pope because that's the freight car door there. It came, as I say, from Fort Wingate. They had lots of it down there. Okay, we've seen this, more of this than we need, but there it is. And Jumbo was a huge steel casting that was designed by our own Bob Henderson, who was former vice president here at Sandia Labs, but he was at Los Alamos then, and he designed this huge, huge forging. And the idea of this was, they thought of this fairly early, and plutonium was in very short supply, and wasn't being made very rapidly, and they decided, if this thing is a dud, and we scatter that very valuable plutonium all over the countryside, and that'd be a crime. So we're going to put it in this vessel, and then if it's a dud, it'll withstand the detonation of a few hundred pounds of high explosives, and then we'll contain the plutonium. Well, that was many months before the detonation, and in those months in the interim, it was decided if we shoot this thing inside that huge steel forging, all the weapons effects are going to be gone. All the energy will go in burning up in vaporizing all this steel. And this thing weighed 214 tons, was 25 feet long, 10 feet in diameter, and I've forgotten the thickness. What was it, Jerry?
12 inches of steel, and then 12 inches of concrete, and then steel bands.
Steel bands, yeah. So it was a very stout. But this is me, and I'm lifting this off the tray. And that's Neil, another guy in our photo-optical group, Neil York. He stayed in the Army when we all got out, and he got in the Air Force, and they sent him to school. He got his PhD, and he then, after his Air Force career, he went to work for Boeing, and he was there his entire career. I think it's this way. It's a little hard to see, but this is South 10,000. It's the only picture I could find of that. This was the central control, and you can see the shadow of the airplane that took this picture, a little bird, I don't know where it came from, but all the communications and signals came from here. This is where Oppenheimer and Fermi and some of the other physicists stood when the bomb went off, 6 miles south. And this, for some reason, has been torn down. It isn't there anymore. I'm going to show you a few of the... These are single frames from the 35 millimeter motion picture cameras. And this is, well, it doesn't give the time after 0 on this one. But these bright spots were of great interest to the physicists. These were probably irregularities in the explosion itself. It didn't seem to deteriorate the explosion hardly at all. This thing went much larger than most of the physicists involved in the design had thought. This went at equivalent to 20,000 tons of ordinary high explosive. Now, by today's standards, that's a pretty small nuclear detonation, but that was, of course, the largest explosion in the world up to that time. 20 kilotons. I'm going to go through these. This is 6 thousandths of a second after 0 time, and it's a little over 100 meters in diameter. And you can see it's quite spherical. That was, everybody was very pleased with that. 6 thousandths of a second. Here's somewhat later, 20 seconds after 0 time. And it had cooled down quite a bit by that time, and this camera was obviously set stop down. We had to set for every camera we had to have 3 cameras. We had to set one. Nobody knew how bright this is going to be, and so we said, well, we'll set one for kind of a dud. We'll open the lens wide open and open the shutter wide open and get as much light on each picture as we could. And we'll set one for kind of a normal, what we think might be a normal explosion, and then we'll set one for a really big explosion. So that's why we had to have so many cameras. Nobody knew how big this was going to be. That's a pretty good picture, 15 seconds after 0 time, and this dust here that's a road that came from ground zero radiating out. And this is from north, so that's radiating out north, looking south. So that's going west. That's the road going to west 10,000. And it was thick with very fine dust. So as the shock wave ran down that road, it just stirred up the dust. And they actually used that, and they went out and made some measurements. And they used that that's not a column, that dust on the road to measure the velocity, optically measure the velocity of the shock wave. And I understand it worked out fairly well. We knew that we had time marks on the edge of this film every millisecond, so we knew the time of each exposure. Another pretty picture, 20 seconds after 0 time. We had 2 barrage, I didn't have anything to do with it, but the guys who measured radiation and radiation effects had 2 barrage balloons up, and the thermal wave, of course, when this thing went off, the heat, particularly close, that's the thing, even standing there 6 miles away, one of the biggest impressions was, wow, the heat that you felt from this ball of fire. But this close in, the center is right down here, and it's only 0.42 seconds, 420 milliseconds after 0 time. These barrage balloons are, of course, being consumed by the flames, and these cables with the data cables coming down being consumed. And the shock wave is right in this general area. But the thermal is the first effect. And at Hiroshima and Nagasaki, that was a very important military effect, the thermal. This is 300 milliseconds, and you can see the barrage balloons burning. This isn't worth showing. This is here's sequential frames from a camera, and you can see this, these things, everything being consumed here. Somebody was doing some data reduction with that. Now we had, as I mentioned, some Fastax cameras at several thousand pictures per second at 800 yards. And these are the results of that, one of those cameras. And we didn't we missed, this is a pole line with the communication and signal data coming down the pole line, and had we thought of that, we could have moved either the cameras or the pole line. It didn't hurt the photography very much. But this was very important data. You can see the growth of the fireball here, fireball diameter versus time. This was, whoops, upper. Oh, I turned something off. Lamp, upper, there we go. Does that work? Not quite. Now what have I done? I don't think I've hit. Oh, thank you. upper. I want lower, don't I, on the base. There we go. Now white, oh, that's it. Yeah. And you can see there's a little background fog here. As I say, these things were 800 yards away, so for several hours after zero time, this film sat in the cameras, even though we had it in boxes with 13 inches of lead. And the cameras didn't point right out, they pointed straight up through 13 inches of leaded glass. It was also called X-ray glass, which was lots of lead in the glass melt. And they looked straight up, and then we had a mirror over each one of the 4 ports. And it was quite a challenge to get these cameras lined. We spent a lot of time, nights out here. We had put a light up on the tower and try to get these cameras pointed directly at the explosion. And this was very valuable data. Okay, and our 20-mile station was at Campagna Peak. You'll see those just very soon as you enter the test area up there. These Campagna Peaks are, Campagna Peak is shaped like a bell, and you'll see them out there. And we had aircraft mapping cameras on each of those 2 hills. We had wires between them. Here we're stringing the wire between these 2 hills. They were about half a mile apart, I would guess. And that's a mile of field wire right there. So that they could trigger, York was there, and he had an intervalometer, which sets the interval between exposures. And it took about 4 or 5 seconds for this is 9-inch wide film, and it got pictures with 9-inch square negatives. So it took a while to move the film, but these cameras worked out very nicely from 20 miles. I'll show you some data from them here momentarily. Here's the peak of that hill. And here's some data from those cameras. And this data was unique in one way. It showed, you notice these clouds above the detonation. These are the only cameras that really showed those clouds. And this is like a physicist's cloud chamber when the compression wave, the positive part of the compression wave goes, maybe I didn't tell you, but it rained. We were supposed to detonate this at I think it was 4 o'clock in the morning. And at 4 o'clock in the morning, it was raining. The first rain we'd had in weeks, but it happened on the morning of the 16th. And some of the signal wires had shorted the ground, and we couldn't shoot in the rain. And so we waited, but they said, stand by at your stations because we may fire up again. We may start to count if it quits raining, which it did in time for a 5:30 shot. But this layer up here was saturated, and the shock wave, the compression wave, went through, and then the rarefaction wave coming back. In other words, the air moves, if this is the explosion, the air moves out this way and then comes back. So you get a compression wave and a rarefaction wave, and that's just like a physicist's cloud chamber, and it formed these clouds, which hung in there for quite a while. This wasn't seen on any other cameras. So we lucked out. This is a single 181. And again, you see the dust on the road right here. But as I say, this was from 20 miles away. Okay. And somebody got the idea of make a comparison. There we got the Washington Monument. However high that is, I don't know. Here's one. I'm not going to take much time to explain, but you see how black this black part here? That's photographic reversal. That's a phenomena that occurs, and those of you who know a lot about the photographic process understand that that happens when you overexpose a negative, extremely lots of overexposure. It causes reversal. In other words, that should be white, but here it is black. And a lot of our film was, these first few frames were reversed like that because they were tremendously overexposed. Oh, and you can see the barrage balloons again in this. Well, you can't either. I can almost see them up in here. And this is from a magazine, forgotten which one, well after the war. And we had, I may have mentioned that we had some cameras that had wide open lenses and a big shutter opening. And we actually burned holes in the first couple of frames on some of those cameras. It was so bright. And you remember the burning glass with the sun? When you were kids, you'd burn the ants or light fires in the leaves or something. Well, that's what that is, a hole in the film. And Dr. Mack, I think, was the author of this article, and this is the reversal phenomenon here. Dr. Mack wanted to have a pinhole camera. Well, he settled for a camera with a 1 meter focal length, and the shutter opened and it took a picture of the entire event for many seconds. And this is what we got, and I don't know what use it. I don't think it was very valuable, but it was a noble experiment. Another similar picture with the barrage balloons. And that's enough of that stuff. Let's look at, here's a 800, this station was right beside our Fastax camera station at 800 yards. These guys were measuring radiation effects, prompt radiation from the explosion. And you see they're all suited up and with masks and so forth. This was the morning after. And this is the morning we came in to get film from almost the same location. And there I am waiting. We're all suited up here to go in to get the film out, and that's me. And this is the 10,000 yard north, the central control station. You can see the control wires, communication wires going out. And this is an interesting structure up here. You'll see pictures of this shelter without this. But about 2 weeks before the explosion, Dr. Mack asked me to come back to Los Alamos, and the bosses, Dr. Oppenheimer and Dr. Fermi and others, were going to be in this shelter. And if they're in there, they can't see the event. So he said, get one of these 2 meter focal length lenses and go over to the carpenter shop and build this. And then we had, I think they were 8 by 12 inch mirrors, something like that. Front surface mirror here, and the one up on the other end, which pointed toward ground zero. And we had a lens, and we had this open so we could focus the lens onto the ground glass screen in the structure. So this was an addition about 2 weeks before the event. And I talked to some of the guys that were in the station. I said, how'd our periscope work, you know? The guy said, I don't know, I was busy with this, and the other said, I was busy with that. One of them said, oh, anybody who wanted to see it went outside. No, I don't think anybody looked at that thing. So, like a lot of experiments up there, it didn't all work. 28 hours after zero time, a mapping camera, an aircraft with mapping camera came over, and Trinitite is a name you'll hear when you get down there, or you probably may have heard it already, but this was the location of the ground zero right here, and the tower was here before it got vaporized. And the explosion was so incredibly hot that it melted the sand, the desert sand down here, and turned it into a crinkling glass, maybe an eighth to a quarter inch thick. And it's primarily green in color. And if you've been to the museum, you've probably seen their pieces of what is called trinitite. But this whole black area was covered with that melted glass trinitite. And this was our May 7th shot of 100 tons. You can see there's quite a difference. And there's 100 meters, so this was several hundred meters across. And that was 28 hours after the event. And about 2 or 3 days after this, I went back to Los Alamos, and I got a couple of paper bags, and as I drove by from base camp, I drove by here, and I went in and I filled up both of these shopping bags full of trinitite, because I knew the guys, my buddies back at Los Alamos, would want some of this trinitite, because everybody was collecting it already. So I took this stuff and I remember I put it on the seat of the car right beside me and drove back to Los Alamos. And that stuff was still pretty hot. I don't know what kind of a dosage I got in that time, but it could have been significant. But this stuff is still valued highly in some places. You'll see it over in the museum if you haven't already. And one of the guys I took it to up at Los Alamos, he worked in the plastic shop, and he fixed me a round piece of plastic with dome shape on it, and he embedded a couple pieces of this trinitite in it. And I had it for a long time. I don't have it. I don't know what happened to it. Do you know? It's my son. Okay, the most significant event of the 20th century, Trinity. Let's see, how are we doing? Wow, we're a little over. Here's a set of interesting dates. On April 12th, President Roosevelt died. April 25th, Stimson and Groves briefed President Truman. President Truman, when he took over after Roosevelt died, he didn't even know about this project. The Soviets knew about it, and the British knew about it, but not Truman. He was vice president. So he was, on April 25th, he was briefed. And on May 7th, which is the date we shot the 100-ton shot, the German armed forces in Europe surrendered. That's VE Day, May 7th. July 16th, of course, was Trinity shot. And, a plutonium implosion bomb at Alamogordo. Now, the gun-type weapon was never tested. It was just taken over to Tinian and dropped on Hiroshima on August 6th. That's the gun type, the little boy. And on August 9th, 3 days later, the Fat Man, the plutonium bomb, was dropped on Nagasaki. And there were about 70 to 100,000 people killed in each of these shots. On August 14th was VJ Day. The Japanese finally surrendered. And on September 2nd was the formal signing. You've probably seen pictures of the Japanese on board the Missouri and MacArthur there, and they're signing articles of surrender. Unconditional surrender. But another important date is me. I got discharged from the Army. Oh, we don't have a date on it, do we? Well, it was February of 1946 I got out of the Army. I have to modify that. The Provisional Engineer Detachment, which were the MPs, the cooks, and the bakers, and the truck drivers, and the craftspeople that we had, and there's Lieutenant Bush, lined up for a picture. I don't know why, we had all kinds of photo facilities, but we never did this. The the provisionals did. And now we're almost at the end here, gentlemen, ladies. This is, I think, Hiroshima, maybe Nagasaki, after some of the guys from Los Alamos, Dr. Penny, who had an office near our lab at Los Alamos, brought some of this stuff back. And this is Hiroshima, I think, after the detonation. Here's more of the same. And some of the Western-style buildings stood up a little bit better than the Japanese buildings. But these cities were destroyed. Well, here's a trolley car still in operation. And each of us got one of these when we finished. You can't hardly see it, my name's on there. But this, I think everybody up there got one of these. All of us in the Army, at least, did. Manhattan District Engineers. And with that, I will ask, are there any questions?
How many people total were at this area when that bomb went off?
You mean our test at Trinity? There were about 180 people actively involved in it. And I read that in a fairly recent Los Alamos publication. And then there was couple of busloads of people, the physicists at Los Alamos who were involved in the design of these bombs, but who didn't have anything to do with the test. They wanted to see it. So a couple of busloads came down, and they stopped at the 20-mile station. The test director didn't want them down at our manned stations at 6 miles, so they stayed there. So there weren't very many people who actually saw this. But yeah, about 180, maybe 200 people working there that saw it.
Was the gun-type weapon ever tested?
No, the gun-type weapon was not tested. They took it directly to Tinian Island and detonated and loaded it up and flew to Hiroshima, and that was the first use of the gun-type weapon.
Why did they use the implosion-type weapon first if they knew it was tested?
Well, they didn't want to drop a dud and waste all that plutonium. They wanted to.
Well, I mean, you said that the impulse-type weapon was tested at Trinity, and they knew it worked. It worked going to ensure better success.
Well, they were quite sure, as I understand it since then, physicists were quite sure the gun weapon would work. It just seemed inevitable. Where you took a section of a big gun like a 16-inch Navy gun, and you put half of the uranium here, half of it here with a big load of explosive, and you just shot it down this gun barrel, and the two joined together and became supercritical, and the neutron flux was such that it detonated instantly, and it worked. And they had done enough in the lab to think that thing would work, but they weren't sure about the plutonium. Now, the plutonium bomb was much more efficient, and there were very few gun-type weapons made after that first one. There were a few. Next, yeah.
Why is it called Trinity? The site?
Nobody knows. Dr. Oppenheimer chose that name, and he was asked afterwards why, and he said he didn't know why he chose that name, but that's the way I've heard it.
Did they ever do a medical follow-up on the people there?
No. No, 6 miles, we had radiation measuring equipment at those stations, and it wasn't enough to harm anyone. Now the fallout, we were at 6 miles west, and the wind was kind of from the west, so the fallout went east, we didn't have any manned stations east. They were north, south, and west. Although there was some danger to, you've read things about the cattle over there and about the some of the cats on some of the ranches, and I don't think anybody got lethal doses over there, but the cows, the hair turned gray on their backs and things like that happened, or supposedly. I never saw any, but that was the word we got.
What kind of censorship did they impose upon you guys that when you worked there?
Censorship? Well, all of our mail from Los Alamos, that we sent from Los Alamos was censored. And if you said anything in there that they didn't like if you talked about the mountains, they didn't want your next of kin knowing that you were in a mountainous area. And so they were overly cautious, I think. And incoming mail was looked at. I don't know what they looked for in that, but
What did it sound like?
the sound was, well, at 1,100 feet a second, it took a little over 30 seconds to get the 6 miles. So we were talking about what a great event it was, and the ball of fire was still somewhat luminous. But suddenly this big kaboom, the shock wave came right, of course, at the speed of sound along with the bang. So it surprised a lot of us. We knew there was going to be a bang, but we'd forgotten all about that in the 30 seconds, and we're looking at the light output of this thing, and then the shock wave came along, and it was quite a shock wave, but it wasn't enough to knock anybody down. I understand at South End that somebody got knocked down, but I was still standing up on the roof of this structure and didn't get knocked down.
How close did you say to ground zero you put the closest cameras?
At 800 yards.
And did they survive?
Oh yeah, we had up at the shop at Los Alamos, we built quarter-inch steel box with 2 walls on each side, 13 inches apart. And this box had a central area, maybe 3 foot by 3 foot approximately, enough for 4 of these Fast-Ax cameras. And then it had a cover with 13 inches of same kind of structure, but it had the holes in, and we put 13 inches of this leaded glass, 4 inches square leaded glass over each camera, and then a mirror at each one. So the mirror, of course, got blown away, but not before we had these very fast pictures. But we did, when we went in to get the film, the physicists knew it would probably be fogged by the radiation. The radiation is just like light falling on the film. It blackens it. So the longer it stayed down there, the darker it would get. So we went in early at 10 o'clock, and we were in a pretty good radiation field. I remember a shot then later at the Nevada test site in the winter of 1950 and 51, airdrops, and we were out again with some photographic equipment, and it was the winter time, and so a guy came by on a bulldozer, and we had him bulldoze out, and we piled some wood on top of that. We made ourselves a place to get out of the cold, because we'd get out there at midnight, and this shot wasn't until 3 a.m. or something. And nobody had thought about making a shelter for the poor guys that were out there working these stations. But anyhow, we were out working on the camera equipment, and the shot went off, and we were a long ways away. I've forgotten how far. And one of the guys he had watched this thing, but he was just coming out of this underground thing we had. He says, "Why, that wasn't too bad, was it?" And just then, God, boom, the shockwave knocked his hat off. And that happened quite a bit out there at the test site.
How far was ground zero from base camp?
Oh, about 10 miles. General Groves was at base camp along with some other folks and he and Oppie had decided they shouldn't be in the same place. Dr. Oppenheimer was at 10,000 yards south, 6 miles south. Oh, I'm sorry. Yeah, 6 miles south, yeah.
Was Trinity built just for the test, and was it abandoned right after the test?
Yeah, it was built just for the, there wasn't much building. The base camp was, you saw it, it was old buildings brought in from some CCC camp, and the contractor fixed them up to some, they were reasonable inside, and the mess hall had a lot of good equipment in it and so forth, but there wasn't much spent on. Now, they spent a lot on, they made a lot of roads down there that, some of them were not very good, but the road from Pope to bring Jumbo from, I didn't go into that, did I? Well, that's okay, we'll do it. But Jumbo, this 214-ton thing, a special trailer was made with 8 rows of 8 wheels, 64 wheels, and they built a special road, 25 miles from Pope, and the road was a very good one. It was earth road, it wasn't surfaced, but it took three bulldozers to drag that huge tonnage up the hill. Fortunately, it was a pretty gentle grade all the way up to ground zero. But Jumbo wasn't used. It was, and General Groves and others were pretty, well, they were secretive about it. They didn't really want people to know that we spent a couple $1 million or whatever it was on this thing, and then didn't use it. But so they tried to get rid of it. They tried to blow it. They put explosives in it and had a problem. It didn't do anything to it. And then they put a whole bunch of 500-pound bombs, wasn't it, Jerry?
Yeah, 3 500-pound bombs.
They put 300.
They set it on the base, and the force went to the end and blew both ends out.
Both ends, yeah.
Duty center.
These hemispherical ends.
Yeah. That's
Yeah.
the first thing you'll see when you go down there is Jumbo, what's left of it.
Tomorrow you'll see Jumbo. It's huge. You won't miss it there. It's right near the entrance to ground zero. And,
When was Los Alamos started, and in what year?
oh, I think 42.
42.
Yeah.
We're kind of running out of time here, so we need to wrap it up, folks.
Oh, okay.
I'd like to express our appreciation to you for doing that. We'll have a chance to maybe talk with Ben individually afterwards, but we have time constraints here at the auditorium.
Oh, we got to get out of here. Okay.
So I thank you for doing all that.
Thank you.
Some quick instructions for tomorrow. Please remember that the bus does leave promptly at 6, so we ask you to come 5:30, no later than 5:45. We'll load the buses at 5:45 and be out of there right at 6. The museum will be open for restrooms only, but there will not be any coffee or refreshments. If you'd like to bring coffee, please bring your own in a thermos for the bus. There will be refreshments available to purchase both at Trinity site and at Socorro, New Mexico Tech, and we will provide lunch as part of the tour tomorrow. Thanks for coming tonight. Don't forget to get some rest before our early departure in the morning. Good night. Thank you, sir.
You're welcome. Sorry I went over, but
Yeah, it's no problem. I think I'm very enjoyable.